Welcome back, everyone. Let's jump right into today's explainer, because we are tackling a really fundamental concept for the Texas 904 exam, specifically Competency 008C. We're going to master how to distinguish between physical and chemical changes in matter. Now, I know what you're thinking. Physical and chemical changes. That's pretty basic, right? But pinning down exactly how to teach this distinction to elementary students, that is absolutely crucial for building their foundational understanding of science. We really want to push them beyond just memorizing textbook definitions so they can truly grasp the actual mechanics of matter.
To get started, I want you to picture a classic split-screen demonstration. This is exactly the kind of setup you're going to use right at the front of your future classroom to hook your kids. Over on the left side, you demonstrate a physical change. Maybe you're melting an ice cube under a warm lamp, or simply tearing a piece of paper into pieces. But then, you look over to the right side, you mix baking soda with vinegar and just watch it wildly erupt. Or you strike a match and let it burn. What is the actual fundamental difference here? Well, one side shows simple changes in state or shape. The other side showcases dramatic, totally substance-altering reactions. And as educators, our primary goal is to help our young scientists immediately recognize that invisible line separating these two types of changes.
Okay, let's dive into this, because this concept right here is your golden rule. We are looking at what I like to call the identity shift. This is literally the ultimate conceptual bridge for your students to cross. Here's how it works. A physical change alters the appearance of a substance. So it might look a little different, it might feel different, or it might take up a totally different amount of space, but the substance keeps its original chemical identity. A chemical change, however, that completely breaks the identity. The molecular makeup is entirely transformed to produce something brand new with totally unique chemical and physical specifications. Think of it like this. A physical change is just a wardrobe change, but a chemical change, that's becoming an entirely different person.
Let's see how this identity rule applies to some super common classroom examples of physical changes. We're talking about melting ice, freezing water, evaporating alcohol, dissolving sugar in water, and tearing paper. Now, what's really fascinating about this is that to a young learner, every single one of these actions might seem incredibly drastic. Think about it. Stirring solid sugar into a glass of water until it just entirely disappears? To an 8-year-old, that feels like literal magic. But you have to guide them right back to that identity rule. Is the melted ice still water? Yep. Is the sugar still in that glass of water? Have them take a tiny sip? Absolutely, it's still there. These changes merely alter the form, the physical state, or the size of a substance without ever touching or creating a new chemical identity.
So the absolutely crucial point is this. How do we actually prove to our students that a chemical change happened? Well, this is where you get to put on your detective hat and train your students to investigate the scene. There are 4 verifiable pieces of evidence, 4 primary indicators that a chemical reaction has taken place. Number 1, unexpected temperature shifts. Things might suddenly get super hot in an exothermic release or surprisingly cold in an endothermic absorption. Number 2, an unexpected color change. Number 3, the production of a gas. So you tell them to look closely for bubbling, fizzing, or smoking. And finally, number 4, the formation of a precipitate. You really need to treat each of these indicators as vital scientific evidence, because if your students can spot these clues, they've cracked the case. An identity shift has definitively occurred.
Let's pause on that 4th indicator for a quick second, because it brings us to a truly fantastic vocabulary word, precipitate. It's a bit of a mouthful, right? We define it as a solid that spontaneously forms and falls out of a liquid solution mixture. Imagine this. You're mixing 2 perfectly clear liquids together. And then, bam, suddenly a cloudy, powdery solid appears out of thin air and settles right at the bottom of the beaker. Honestly, it's often one of the most complex vocabulary terms your elementary students are going to encounter in this whole unit. But by defining it clearly as a brand new solid falling out of a liquid, you are fully preparing them to use precise scientific language. You're actually teaching them to speak like true chemists.
And this brilliantly illustrates the need for a great pedagogical strategy, the think aloud. Imagine standing in front of your class, projecting a picture of a really rusty old bike up on the board, and posing this exact question aloud to the room. How do we know the iron in the bicycle rusted instead of just getting dirty? Well, think about it. A dirty bike is just a physical change. We can take a hose, wash the mud right off, and the shiny iron is still sitting right there underneath. But rust? Oh, rust is stubborn. The iron actually reacted with oxygen and moisture in the air to create iron oxide, a totally new substance. By modeling this specific thought process out loud, you show your students how to look for the irreversibility of a change as their ultimate clue. Because at the end of the day, you can't just wash away an identity shift.
Ultimately, this brings us to the most important question for your own teaching practice. How will you challenge your students to look past mere appearances and investigate the true identity of matter? Because really, that is what science education is all about. It's not just about watching baking soda fizz or seeing ice melt for fun. It's about asking why and proving what happened down at a structural level. Armed with the concept of the identity shift, those 4 vital indicators of a chemical change, and great strategies like the Think Aloud, you are completely ready to turn your classroom into a literal laboratory of detectives. Thank you so much for joining me for this explainer. Now get out there and inspire some incredible scientific discoveries.